Hello friends, welcome to EC Academy.
In this lecture, let us understand latch-up in CMOS. So latch-up is failure condition in CMOS circuit. So latch-up is one of the important failure conditions in CMOS. So it is a condition where low resistance conduction path is established between VDD and VSS. So latch-up is a condition where a low resistance conduction path is found between VDD and VSS. Due to this low resistance path that is formed between VDD and VSS, a heavy current will flow between VDD and VSS. So this heavy current will damage the device. So this latch-up condition will occur due to parasitic bipolar transistor. So this latch-up condition occurs due to parasitic bipolar transistors. So if we say parasitic, which means these transistors are not available, but later these transistors will be formed. Such type of transistor we call this as parasitic bipolar transistors. So we can say these parasitic bipolar transistors are unintended transistors that cause a short circuit between VDD and VSS. To understand the latch-up condition, let us consider a CMOS structure, and this is the cross-sectional view of CMOS structure. So this CMOS structure consists of NMOS in a P-well and PMOS in n-substrate. Due to this, two transistors are formed. These transistors are known as parasitic transistors. So an NPN transistor is formed due to N plus source or drain in NMOS, P-well and n-substrate. So these will form NPN region. That's why an NPN transistor is formed. So here the emitter terminal is due to N plus source or drain. The base terminal is due to the P-well and the collector terminal is due to n-substrate. A parasitic PNP transistor is formed where emitter is formed due to P plus source or drain in PMOS. Base is formed due to n-substrate and collector is formed due to P-well. As you can observe, the base of NPN transistor and collector of PNP transistor are connected because both the layers are formed due to P-well. And there will be small resistance that is offered by NPN transistor, that is written as RW, and resistance offered by PNP transistor is RS. Now we can write the equivalent circuit for this parasitic bipolar transistor. So this is the equivalent circuit for parasitic transistor. By considering this circuit, we'll understand how high current flows from VDD towards VSS due to latch-up condition. So from this circuit, we can understand that the VDD is connected to the emitter terminal of the PNP transistor. So from this CMOS circuit, we can easily understand VDD is connected to the emitter terminal of PNP transistor, and base of this PNP transistor is connected to VDD through the resistor RS. So you can see through the resistor RS, base is also connected to VDD. So the collector of PNP transistor is connected to base of NPN transistor. Collector of PNP transistor is connected to base of NPN transistor, as you can see from this structure. And emitter of NPN transistor is connected to VSS, and base of NPN transistor is connected to VSS through the resistor RW. So from this structure we can understand the emitter terminal of NPN transistor is connected to VSS, which is ground, and the collector terminal is connected to base of PNP transistor. So PNP transistor is T1, NPN transistor is T2. Now if you observe this circuit is similar to the two transistor model of SCR. From the working of SCR, we know that once a positive voltage is applied to SCR, it will start conducting very high current. The same process will happen here. Since VDD is connected to base of the transistor T1, the transistor T1 will turn on, and since collector of T1 is connected to base of T2, once transistor T1 is on, transistor T2 will also turn on. So once both the transistor will on, it will establish a path between VDD and VSS, which will act as a short circuit between VDD and VSS, and a high current will flow through this circuit, and high current will flow through VDD towards VSS. So this high current, again due to the amplification that is caused by both transistor T1 and T2. So if high current flows between VDD and VSS, this will damage the CMOS circuit. So how to prevent latch-up condition? So we can prevent latch-up condition by providing substrate and well contacting, which means every well should have substrate contact. The substrate contacts should directly be connected to supply pads using metal. Second method is transistor placement guideline. So if we say transistor placement guidelines, which means there should be a separation between PMOS and NMOS. Next, we can use guard rings. So we can use guard rings like we can use P plus around NMOS and N plus guards around PMOS. By this, we can prevent CMOS from latch-up condition. I hope you have understood this topic. Thank you.